What is the angle for this one right here?
30.
That one's 30. That's right. We worked on these dudes. What's the angle for this one right here?
45.
This is a 45 one. And then what's the angle for this last one?
60.
60. So even though the 30, 60, 90 triangle, the 30 degrees and the 60 degrees come from the same triangle, I'm going to call this one the 30-degree triangle and this one the 60-degree triangle. I'm going to treat them as something different. They are slightly different. Can you guys pull out those little triangles that we cut out and wrote on? The measure of the horizontal side is rad 3 over 2. Let's do a different color. I want it to pop. Rad 3 over 2. Okay, that's the 30-degree side, and on the 30-degree triangle, it's the horizontal side. Okay, so if that's rad 3 over 2, what is the vertical side? 1/2. And then what about my hypotenuse? Uno. Okay, now let's do our 45, 45, 90. All right. Let's call on somebody. Here we go. We're going to go with, where is that? Eric. What is the measure of the hypotenuse for the 45, 45, 90?
For the hypotenuse, 3 over 2.
Nah, this guy right here. And I'm talking about the hypotenuse. Remember, these are in the unit circle.
Oh, 1.
Uno. Oh, very nice, very nice. Okay, what about our horizontal side? Amanda. Where you going, Amanda? Amanda, what's the measure of our horizontal side for this triangle? Rad 2 over 2. Very nice, very nice. Okay, now this is a 45, 45, 90, which means the vertical, the height line also is rad 2 over 2. Now what about our 60-degree angle or triangle right here? What is the measure of the horizontal side on this one? We got a 1/2. Very nice for the horizontal side. Okay. Hey students, all together, what is the measure of the hypotenuse here? Oh, come on, guys. Uno. Okay, what about our vertical side? If this side is 1/2, then this side must be. Very nice, students. Very nice. Okay, we are going to use these triangles to help us find these. Now, I know you guys probably use the unit circle, and that's okay. Okay, but we need to practice. So can you guys grab a dry erase marker out of your bin and get ready to draw on your desk? Here we go.
I like this. I like drawing on the
I want you guys to graph 120 degrees. Graph 120 degrees. Now, it should look something like this. Start yourself out. And you guys know a few things. You know this is 90 degrees. You know this is 180 degrees. You know that this is 270 degrees. And this is 360 degrees. Starting at 0. Here's what I want you guys to graph. 120 degrees. With the terminal side and everything. Do you guys know what quadrant we are in? The second quadrant. How do we know that? Because the angle we are working with is greater than 90, but less than 180, right? Okay, so we know that we're going to go past the 90 and stop somewhere in this quadrant. It doesn't matter where right now. It doesn't have to be exact because we're not measuring. And then you draw a terminal side out. It would look like this. And then you draw your triangle. Whenever you draw your triangle, you draw a line, a vertical line, straight back to the x-axis. So we're going to draw a vertical line straight back to the x-axis, like so. There we have a triangle. Now the question is, which triangle is this? Is this the 30-degree triangle? Is it the 45-degree triangle? Or is it the 60-degree triangle? Talk to your neighbors and figure it out. I walked around, heard what you guys said, saw what you drew, and you guys are doing a really good job. This one is a 60-degree triangle, but it is not 60 degrees because it's tall. Oops. It is 60 degrees because 120 plus 60 will equal 180. That's why. Okay, does that make sense? See, that's what I said before. I said it doesn't matter where you draw this because you can use the numbers to figure out what triangle it is. Now, this is a weird thing. There's two types of people in calculus. There's people that really understand this and they don't need much explanation. And there's people that are just kind of like, what? I get that. All right, so if you're the first person, try to get the other people to your side. Okay? Okay. All right, so now, do we know the side measurements of this triangle?
Yes.
We know it's a 60. So what's the measure of the horizontal side? That's this thing right here. It is 1/2. Very nice.
Negative 1/2.
Oh, wait. Do you guys agree?
Yes.
Is that negative? Oh, very nicely said. Good catch. What about the vertical?
That's
Rad 3 over 2. Very nice. See, we're kind of copying this thing right here. And our hypotenuse is? Uno. It doesn't end, people. It doesn't end. Okay. Now, if we're over here and we're trying to find out what sine of 120 degrees is, you just need to think of what sine is. Do you guys remember what sine is? Sine is? Oh, you guys already know the other shortcut. Very nice. Sine is the y.
Yes.
Okay? But before you knew that, what else did you know about sine? It was opposite over. So I'm going to say O over H. And what's cosine? A over H. Soka. Toa. Okay, and if you went and looked at a right triangle, if this theta right here was the angle you're referring to, the opposite side, would it be the horizontal or the vertical? The vertical would be the opposite side. This is your O. This is the opposite side. And then this would be your adjacent side. Adjacent means right next to, and this is your hypotenuse side. Okay, I'm just writing that down for reference, just in case you guys forgot. So now, if I look over here at my sine of 120 degrees, I just do opposite over hypotenuse. What is opposite of this angle? Rad 3 over 2. So I'm going to put rad 3 over 2 divided by, and what is the hypotenuse? 1. Divided by uno. Now, do we need to divide it by 1?
No.
No, it's the same. So that's why you guys just said, it's just the y value, Mr. Patey. It's the y value of the points right here. That point is 1/2, negative 1/2, and rad 3 over 2. Cosine is adjacent. Adjacent over hypotenuse is cosine. And so, let's see, this side's the adjacent side, and 1 is our hypotenuse. And so we have negative 1/2 divided by 1, but again, we don't need to divide it by 1. And we have our two answers for 120 degrees, the sine of 120 degrees and cosine of 120 degrees. All right, so now I want you guys to graph 300 degrees. Because 300 is between 270 and 360, you know that we would go all the way around to here, about right there. Some of you guys put a dot right here, and that was excellent. You just need to connect the origin to that dot, and now you have your terminal side. Remember, this was the initial side, and this one was the terminal side. Okay, now how do I draw my triangle, though? Do I go this way, or do I go this way? Yes. You always need to have a vertical side coming off of the point right there. Okay, so what is this side now? What is this angle right here? Did you guys figure it out? I mean, if this is 300 degrees, how much more would you have to go to get to 360? You'd have to go 60 more. Very good, very good. Now, do we know the measures of all our sides?
Yes.
Yeah. What's the measure of the 60 degree side? Look at this, look at this. What's our 60 degree side? Right there. This would be, is it negative or positive?
Wouldn't it be negative? No.
It's 1/2. This is 1/2. And we know it's 1/2 because the triangle we're using is the 60 degree triangle. I know we're using a 60 degree because the 60 degrees is on the origin. And so I put my 1/2 right there. And then what's the vertical side?
Oh, negative rad 3 over 2.
Rad 3 over 2, and now we're going to make that negative. Boom. Now you've got your x and your y. So we have 1/2, negative rad 3 over 2. Do you guys know what sine is? Negative rad 3 over 2.
Yes.
And then cosine is
1/2.
1/2, positive. Sabrina got kind of confused. She was thinking that we were talking about this angle right here. But you're always supposed to talk about the one on the origin, okay? So for sine, we're looking at the opposite side to this angle, which is this, negative rad 3 over 2. All right, the last one. Go ahead and graph 240. Okay, because we know that 240 is greater than 180, but less than 270, we know we're in the third quadrant. So I'm going to stop right there, draw my line. Now, I saw some of you guys drawing your line back to the y-axis, but we're not supposed to go back to the y-axis. We're always supposed to go back to the x-axis. Okay, so don't forget that. Always go back to the x-axis. Now, there is a shortcut to finding what these angles are that we're looking for. You will always use 180 to find that angle or 360. You'll never use 270 or 90 degrees to find that angle. You'll always use 180 or 360. That's for the shortcut. Okay, so if this line right here is 240, and if I'm tracing it, and right here it's 180. How much more do I have to go
60.
to get to 240? 60. So this right here is 60 degrees. So you could have done, what is that, 240 minus 180, and that would have given you 60 degrees. Okay, now the side measures, let's do this really quick. Negative 1/2, negative rad 3 over 2. I got that by using our 60-degree triangle down here. And so our answers are negative rad 3 over 2 and negative 1/2. Now, if you're writing stuff down, make sure you know that these right here in green are the reference angles. What are our reference angles? 30, 45, and 60. 30, 45, and 60 degrees are the reference angles.